Hi, today I'm looking at the paper from 2009, going through question 6. So question 6 says find the range of values for x greater than 0 such that this inequality holds. I think this looks quite intimidating, this question, as we have an infinite sum on the right hand side and an inequality, and it's not something you commonly see together. So the way to think about it is to break it down into things you know. So let's for now just consider the right hand side. What is 1 plus 1 over x plus 1 over x squared plus dot dot dot? Well, we see that is clearly an infinite sum of a geometric sequence with a common ratio of 1 over x. This term differs from this by 1 over x, this one differs from this by 1 over x, and so on and so forth. So we have a geometric sequence with u1 is 1 and the ratio is 1 over x. And we know that the sum to infinity is u1 over 1 minus r. So therefore, we get that this sum to infinity is equal to u1 1 over 1 minus the ratio. Well, that's equal to x over x minus 1. Well, now we have a much simpler thing. Now we have this is equivalent to x plus 2 is less than x over x minus 1. Well, now we can try and solve this. Well, we notice that we might want to multiply through to solve for x, but remembering that we have an inequality, and again, we don't know if x minus 1 is positive or negative. We only have the restriction that x is strictly greater than 0, not that x minus 1 is strictly greater than 0. So we have to multiply through by x minus 1 all squared to ensure we preserve the inequality. So doing that, we get x plus 2, x minus 1 all squared is less than x minus 1. X plus 2 into x squared minus 2x plus 1 is less than x squared minus x. X cubed minus 2x squared plus x plus 2x squared minus 4x plus 2 is less than x squared minus x. So we get plus 2x squared minus 2x squared. So we get x cubed minus x squared. Then we have a x minus x gives us 2x, minus 4x gives us a minus 2x, plus 2 is less than 0. And okay, let's try and think about the function of that. Let's try and think about solving x cubed minus x squared minus 2x plus 2 is equal to 0. And then we can sketch it and find where it's less than 0. So x cubed minus x squared minus 2x plus 2 is 0. Well, what we'll do is we'll use the factor theorem to try and find some roots of this and to factorize it. So we know the way to do it is to sub values in and see if they give you 0. So if we let that equal to f of x, if f of a value of x is 0, then that is a solution. So let's try f of 1. Okay, well, that's equal to 1 cubed 1 minus 1 squared 1 minus 2 times 1, 2 plus 2. Well, that's 0. So great, we have a solution. So we know x minus 1 will be a factor of our equation. So by the factor theorem, x equals 1 is a root. So that means we have x minus 1 as a factor. So let's see if we can divide this to get our other roots. So we use our algorithm. So what multiplies x to get x cubed? Well, that's x squared. So we get minus x cubed. Minus 1 times x squared gives us a minus x squared. So we get a 0, and then this comes down to give us a minus 2x. Then we need what multiplies x to give us minus 2x? Well, that's just simply minus 2. So we get a minus 2x plus 2. Bring that down to give us a plus 2 here. That is 0. So we see this is equal to x minus 1 into x squared minus 2. So that's the same as f of x. And well, that being equal to 0 is simply x minus 1. And that's a difference of 2 squares with x plus 2, x minus root 2 is 0. Therefore, x is equal to 1 or plus or minus root 2. So let's sketch this quickly to find out when it is less than 0. So we know it's a cubic, and it's a positive cubic, so we know roughly its shape is going to be like this. And we know it has a root at 1, plus root 2, and minus root 2. So it's going to look something along the lines of this. Well, we're concerned with being less than 0, so we're concerned with the region down here and here. So we get that x must be less than minus root 2 or between 1 and root 2. But we're told that x is greater than 0, so x can't be less than minus root 2. So we see that the region required is x is less than root 2 and x is greater than 1.